Hello viewers, you are welcome to T-Ben Math class. In today's lesson, we're going to look at straight lines. Specifically, we're going to learn the length of the line joining 2 points. Before we go into it, let's see how the formula for finding the length of the line joining 2 points is derived. Looking at the diagram on the board, there is a line, and the line is AB. So we have a point here. That point is A, and it has coordinates x1, y1. And then there is also another point named B, point B, having coordinates x2, y2. Now, if we are to trace this to the Cartesian plane or the x and y plane, we will have, let's start with the A. We will have the x component here because this is for x-axis. So here will be x1. If we are to trace this one to the y-axis, we will have y1. When we go to the B, the point B, if we are to trace to the x-axis, we are going to have x2. And then when we are to go to the y-axis, we are going to have y2. When this is extended, we will have a diagram, a nice diagram drawn. We will go to it later. Now, x1, x2, if you want to find the length here, or if you want to find the difference, it will be the bigger one minus the smaller one. The x2 is bigger than the x1. It means that we will have it as x2 minus x1. Why? Because this and that are parallel and equal. Now, when we go to the y-axis, the same thing will be done. The bigger coordinate minus the smaller coordinate. So y2 is bigger than y1. So it will be y2 minus y1. If you are to take this one to this side, then it means that we are going to have y2 minus y1. Looking at the diagram drawn, A, B, and then we name here C. Looking at A, B, C, we can clearly see that we have obtained a right-angled triangle. And whenever there is a right-angled triangle, in order to find any of the sides of a right-angled triangle, we apply Pythagorean Theorem. So by applying Pythagorean Theorem, what do? The theorem says that the longest side, in other words, the side opposite to the right angle. So this side is opposite to this right angle. The square of it, so AB squared, should be equal to the square of this, that is AC, plus the square of the other side, CB. It means that the square of the longest side should be equal to the sum of the squares of the other two sides. So AB squared is equal to AC squared plus CB squared. That is all about Pythagorean Theorem. So let's do a substitution. Our AB squared will be equal to AC squared. What do we have for AC? AC is x2 minus x1. So it will be squared. Plus, what do we have for CB? That one too is y2 minus y1. That one too squared. In order to find AB, because there is a square here, you will bring square roots. So we will introduce square root here, square root there. This cancels this. So our AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, we know that whenever we introduce square roots, there should be plus or minus, but because you are dealing with length, in length, there is no negative figure. Negative figures are not considered when we are treating length or when we are finding length. So therefore, the magnitude of AB, the length of AB, the distance between points A and B will be the formula here. So the formula is proven. Let's consider our first example. Our first example is given that point U, negative 7, 23, and point V, 6, 18 are the endpoints of a line UV. Calculate the magnitude, the length, the distance between the point U and that of V. Let's look at how to go about this. The points given are negative 7, 23, and for V, 6, 18. So straightforward, the formula will be written down. The formula says that if you want to find the magnitude of UV, we have in the square root x2 minus x1 squared plus y2 minus y1 also squared. Now let's quickly go into the points and then name them one after the other. This will be called point 1. This will be point 2. So if this is point 1, then the x coordinate there will be called x1. Then the y coordinate there will be called y1. If this is point 2, then the x coordinate there will be called x2. The y coordinate will be called y2. Having gotten this, we will do our substitution. So in the square roots, we are going to have x2. Our x2 has been obtained as 6. So it will be 6 minus, then there is x1 here. x1 is minus 7 squared plus, when we go to the other part, that is the y part, y2 is 18. So it will be 18 minus y1 is 23. That one 2 squared. So we will have 6 minus negative 7 will be 13. So we will have 13 squared plus 18 minus 23 will also be negative 5 squared. Now squaring each of them, we will have 169 plus 25. The sum of the two will be 194. So it will be 194 units. That will be the answer for the magnitude of UV. In our example 2, we have calculate the distance between the points N, 12, 5, and R, negative 3, negative 6. We have the points as 12, 5, and for R, negative 3, negative 6. The formula is written as the magnitude of NR is equal to, in the square roots, x2 minus x1 all squared plus y2 minus y1 all squared. Let's name them. I said in the first example that when we pick this, this will be our point 1. It means that the x coordinate there will be x1, the y coordinate will be y1. This is our point 2. So this will be x2, y2. Having done that, we will do our substitution. So what is x2? x2 is negative 3. What is x1? 12 squared plus, when we come to the y part, the y2 is negative 6 minus y1 is 5. That one 2 squared. In a square root, we will have negative 15 squared plus negative 11 squared. Now let's square each of them. Squaring each of them, we will have 225 plus 121. When we sum them up, we are going to have the square root of 346 units. In decimals, it can be written as 18.6 units to 1 dp. Correct, to 1 dp. So this will be the answer for the magnitude of the line NR. Before today's lesson is brought to a closure, I would like to give you a trial question. The question is on the board. Solve the question and put a solution at the comment section. If this lesson or this video is useful, subscribe to my channel and like the video. We will meet another time for another lesson. Until then, goodbye.